Hi, everybody, and thank you for joining us today. My name is Yves AbouRjeily, and I'm the Regional Business Manager at Innovyze for the Middle East, North Africa, and India. Please feel free to write us your questions in the question box, and we promise to come back to you individually with answers after this webinar. With me today is David Fortune, our Vice President of Innovation. David is one of the leading thinkers in the water industry about the use of digital transformation and digital twins. We've noticed recently a large interest in smart infrastructure and digital twin technology by several of the utilities and municipalities in the Middle East. Therefore, we organized this meeting today to discuss how Middle Eastern utilities can build digital twin and how they can reach their goals using these types of technology. Hi, David, and thank you for joining us today.
Hello, Yves. Well, you're welcome.
Thank you. Can you please start by summarizing your experience in the water industry?
Yes, I can. I'm a software systems technologist and I'm a chartered water engineer. I've got over 40 years experience of designing and producing software systems and over 30 years experience of producing those systems for the water industry. That's for asset management, for network modeling, and for daily operations. Now for me, the worlds of water management and software technology are coming together with digital transformation, with smart networks, and with digital twins. So for the first time since SCADA became commonplace, we're able to automate and optimize network operations, and we can improve service levels, and that really is so exciting.
That's exciting indeed, David. With all your experience, I believe you will help us to understand more the digital twin concept and the way to achieve it too. So can you tell us more about the digital transformation and what it means for water utilities?
Certainly, Yves. Now, my focus today is on networks rather than treatment works. We'll deal with treatment works, treatment plant another day. So I mean water distribution networks, wastewater, stormwater, and flood networks. Now, at Innovyze, we empower water experts around the world by delivering and supporting water engineering software. So we support digital transformation of water utilities. And those utilities have very high expectations. What do they want to achieve? Well, in general terms, the answer is better information, better decision making. And increasingly, utilities are turning to digital twins to provide the answers. Now, whether that's for improved capital planning, prescriptive rather than reactive asset management, that's the way to go now, or my own particular, I suppose, favorite is for more effective operational management. And it's operational management that I want to talk about today. Yeah, let's take a closer look at the benefits offered by digital twins. Now, first of all, I think ensuring continuity of service at expected service levels. Continuity means just keeping that service going. So for water distribution, highly regulated utilities must minimize the length of time that properties are without supply. It's the number one priority. And even for non-regulated utilities, that's still the priority. Keep that supply going. Bursts, of course, we want to be able to identify bursts, know that they've happened, but also locate them really quickly so that they can be fixed and, of course, then supply can be maintained as soon as possible. And managing supply in a more resilient way. So the measure of a good utility is how well they manage problems to ensure service is maintained. It's a bit of a similar story with wastewater and stormwater. Digital twins offer benefits. Of course, predicting and managing sewer overflows and flooding. And of course, reducing pumping costs, always there. So I suppose in summary, better service at reduced cost. Very important. Now we've got customers all around the world that are starting to implement digital twins. And I'm sure that the benefits that digital twins bring are of interest to water utilities in the Middle East. But before we return to digital twins, perhaps Yves, you could summarize the changes to the water industry in the region.
Yes, yes, sure, David. So first, over the past few years, the water industry has seen a huge rise in infrastructure projects set out by many of the countries in the Middle East region. New infrastructure now are closely being tied with utilizing the best available technologies. The countries in the region look to optimize on their existing and also on their future infrastructures. Network operation optimization, maintaining high standards in water quality, planning for rapid new infrastructure at a larger scale, and mitigating flash flood rainfall events are all key factors we have observed over the past few years. In addition, the region in general and the Gulf states in particular have experienced both momentum flooding events in 2018, 2019, and also 2020, as well as long periods of drought, adding pressure to an already water-stressed area. This makes countries in the region looking to invest more into optimizing water use and reuse and also reducing the non-revenue water. Therefore, the use of the right smart technologies which can optimize water use, reduce the water loss, and predict flooding location and timing before it happens is going to be crucial. We believe this will create better decision-making and will be a defining factor in the goals and ambitions set out by the individual countries in the region. With this background, so David, why would you say the digital twin is so powerful? Why does it enable transformation of operations? I believe this is what we're looking to have from this session.
Well, golly, there is an awful lot going on in the region, isn't there, Yves? And yes, digital twins can definitely help. So why are they so powerful? I would say, first of all, because let's not forget that real-world networks are out of sight. They're hard to observe. And there's never really enough monitoring data to tell operations exactly what's going on everywhere. Whereas the digital twin gives us insight. It tells us the flows, the pressures, the levels, absolutely everywhere across the network. Better than that, a digital twin can be predictive. It can look ahead and tell you just how the network is likely to perform in the hours or days ahead. Now, just think how useful to operations that is, being able to predict what is going to happen. So the digital twin can alert you to likely service failures, not just now, but into the future, into the hours and days ahead. And it can give you the control strategies to reduce or remove those service failures. In addition, can help you optimize pumping costs, always important, while still meeting service levels. And resilience. I've mentioned resilience before. It's of increasing concern. The digital twin can help you manage the network when problems happen. And they will happen, so that you can maintain service for as long as possible.
Yeah, that's great, David. So as I mentioned at the beginning of this discussion, we scheduled this talk today because my team has seen a huge increase in demand for knowledge on digital twin technologies when speaking with companies, utilities, or even municipalities all over the Middle East, particularly in the past 2 years. So my question here, why do you think the digital twin is coming of age right now?
Yes, good question. Well, because we do now have the technology that we need to build effective digital twins. We've got more network monitoring than we've ever had before. Not as much as we want. I don't want to stop here. We want more, but we've got a lot more than we used to have. We've got more flexible control of pumps and valves. Again, I'd like every pump and every valve to be automatic or remotely controlled, but we're getting there. And hydraulic models, they're complete, they're fast to run, they represent the whole network, and they can run in a very short time now. And we are getting better at keeping them up to date. So as the real-life network changes, we reflect those changes in our asset data register, and those changes go straight through to the model and update the model. In addition, let's look at some technology that can be there in the digital twin. Optimization. It's getting to be tried and trusted. We know how to do that. And we're starting to make good use of machine learning and other artificial intelligence to give us instant insight into what's happening on the network, faster than a person can do it, and to give advice about what to do in the event that we see differences happening on the network than we were expecting. So we're also improving the way that hydraulic modeling, AI and optimization exchange data and work together effectively. We can do all this now. It's not trivial. It does take work, but Innovyze and our customers, we've learned a lot about how to implement digital twins so that we can get the operational benefits.
That's excellent, David. So that's clear. I think technology and data with optimization capabilities made this possible now. Can you give us some practical examples of digital twin applications before we go in details on how we can build a digital twin?
Yes. Well, what I can do is just mention some of the case studies of digital twins that we've learnt a lot from. So I will start with Thames Tideway Tunnel, very large stormwater tunnel under London. The digital twin that they're using there lets maintenance staff know and construction staff know when it's safe to be in the tunnel, and more importantly, when it's not. So it's a real safety critical application of a digital twin. Bristol Water. Now they're experimenting with working out what kind of operational improvements you can get to water distribution networks if you've got a digital twin in place. And they're also looking at what sort of monitoring, what density of monitoring that you need to effectively drive a digital twin. Now Anglian Water have moved to active flood prediction and management around their region. The whole region now is covered with digital twins predicting flood and looking at management options. Very similar at Portsmouth Water. They're doing the same. Scottish Canals, now they've automated the use of a very old asset, an old water transport canal, and they're using that to soak up stormwater and yet still maintain the navigation in the canal. And what this does is it frees up some very expensive development land, keeps it free from flooding, and allows housing and industry and commerce to be built on that land. So very valuable use of a digital twin. Now, I don't really have time today to describe these case studies in detail, but we're more than happy to go into that detail at another time. And yeah, just talk to us and we'll give you information about those case studies.
So David, based on all these case studies that you've just mentioned, we can see that digital twin can provide several benefits for water utilities and can assist their engineers in different forms in their day-to-day operations. I believe our customers will be interested to know how digital twin can work in their specific cases and projects, and we'll have you on several meetings explaining and highlighting the benefits of these types of projects. Now, I think it's interesting to know what is needed to start building a digital twin.
Oh yes, let's get on to that. Okay, it's an easy answer actually. For water networks, water, wastewater, stormwater, the heart of an operational digital twin is always going to be a hydraulic model that simulates water flows, the pressures, and the levels that are happening in the real world network. And that model is the starting point for building a digital twin, but of course the model needs to have up-to-date representation of the network infrastructure, and it should be calibrated and verified against flow data measured on the real network. Now the model is then truly representative of the performance of the real-world network, so it can be used to support everyday operations as well as longer-term planning. So with that first step, creating and maintaining a network hydraulic model and running it whenever a question needs to be answered, many of the benefits of digital twin can already be achieved. So for water distribution networks, it's possible to design pressure management regimes to maintain sufficient supply pressure, yet reduce the likelihood of bursts and leakage. And when tanks, reservoirs or pumps need to be taken out of service for maintenance, rezoning can quickly be assessed to maintain service. Wastewater and stormwater networks, the potential of overflows and floods can quickly be assessed just using that model as soon as the weather forecast is updated. So a lot of utilities have hydraulic models, hydraulic network models, and they built to answer perhaps a single planning question or some long-term planning questions. But so long as that model is maintained, reflects reality, the real world, it becomes a hugely valuable asset, and it's able to answer so many operational questions.
Yeah, this is great, David. I think you've demonstrated the point on how to start building a digital twin and what are the main benefits of a digital twin at this early stage. Now, can you tell us more on the development of a digital twin? And by starting with a model you trust, where can we go later?
Yes. Well, once water utilities see the benefits of using a hydraulic model to support daily operations, they can expand the capability of the digital twin step by step in a controlled way. So they can add real-time monitoring of flows, pressures and levels in the network. They can start to run the hydraulic model automatically throughout the day, so a user doesn't have to press the button. They can always go to the latest one that's been run. Visualization and control suitable for operations. Now, you might often see modelers' user interfaces being used. They're not necessarily the right thing for operations, so people could start to build and particular visualization suitable for operations. Alarm generation to give the warning of failures and breaks in service. And we can start to use artificial intelligence, machine learning in particular, to help spot those failures of service. And of course, I've mentioned it before, but adding remote control of pumps and then valves as well. That's helping to build up the digital twin, and automated optimization of those pumps and valves, then setting up new set points for pumps and valves so that you can achieve better service levels and lower costs. But the starting point, it's always that trusted hydraulic model. The trust, it's a key concept for digital twins. If operations are going to rely on the digital twin to support everyday operations, then they need to be able to trust the digital twin to give a reasonable, accurate representation of the hydraulic performance of the network. And to build that trust and get that representation, it takes a mix of technology and operational procedures. So we do need rigorous procedures for updating and maintaining the network model from the asset data. So asset data has to be updated and the asset data needs to be fed into the model. Models should be verified and validated and calibrated regularly so that we know they're giving a good representation of the real world. And the model does need to be accurate enough to answer the questions we're going to throw at it. It's a bit of a circular argument because the more accurate the model, the more questions that it can answer. Please remember, metering and monitoring are not always right. Problems will happen from time to time with meters, and the datacomms that connect the meters to the central digital twin. So we've got to be on our guard. We've got to check the data coming from metering and monitoring, and automated data checking can prevent an awful lot of problems. Now, talking those connections, we should make the connections once between the monitoring network and the digital twin, test them, and then maintain them. We don't want to make those connections every time we use the digital twin. And automation in general is the key to dependability. So automate repetitive tasks, test them, and remove the user error that comes perhaps when it's 3 o'clock in the morning and problems are happening and people are a bit tired. Automate everything that can be automated. Now, models, optimization, machine learning, or other artificial intelligence, they need to be well integrated. We are getting better at that, as I said before, but they should be well integrated. Alarm thresholds, they're really crucial, and they need to be developed over time. We can't set them up and get them right instantly. Now, the model is going to produce many more data points, many more data points. That's flows, levels, pressures across the network, even water quality, more than can be produced by monitoring alone. So the potential is there to generate way more alarms than can be managed. So we've got to be careful about alarm setting. The results are only as good really as the demand forecasts and the weather forecasts that drive the hydraulic models. So pay some care and attention to demand forecasts and weather forecasts, get those as good as we can. And I'll return to user visualization. User visualization, use of dashboards, they need to be clear, they need to be simple, and they need to be suitable for operational use.
So that's great, David. So technology, data availability, optimization, and automation also combine to regular checks and updates of the model, or what we call system maintenance, made the digital twin an efficient and applicable technique with lots of benefits, as you just described. At the same time, we expect this technology, that this technology will be used by operators, by engineers, by several and different teams within the same organization. So could you tell us more what other factors should be considered by utilities while enhancing their digital twin so it can be also used more efficiently between different departments?
Yes, I can, Yves. Now, I said at the beginning that I am a technologist working in the water industry, but I have spent many years working with and working in operations. And I have to say that an effective digital twin, it's not just about technology, not by any means. We have to think about the people involved and change management. Let's think about changing the operations culture to make best use of the power of digital twins. And collaboration and communication are vital in order to innovate and produce the changes we want. So operations, data teams, modeling teams, IT departments, and suppliers like Innovyze, we need to be in this together. Digital twin is not a product, it's a grouping of technology, and to get it right, people need to be working together. And in particular, I'm going to mention operational managers. They should be part of the implementation. They drive the requirements and they can ensure success. I'd also say start with a single essential operational aim. The game changer for a particular organization, particular utility. If you get that right, get that success, then move on from there. Then do the next one, then the next and the next. So do it in an iterative way. Don't try and achieve all the benefits at one go, because it's not right to take on too much at once. But begin with that trusted hydraulic model. Yeah, it's the best way. And if you follow that sort of iterative plan, then I think everyone will find that the digital twin really is the key enabler for operations.
Yeah, thank you, David, for this overview. Before wrapping up, can you summarize the benefit for a utility in developing a digital twin?
Yes, I'll do that, Eve, and I'll do it quite briefly. Yeah, I would say in conclusion that we are moving into the age of digital transformation and smart networks, and we're starting to achieve better information on what's going on and better decision making on our operational networks. And increasingly water utilities are turning to digital twins to provide the transformation that we want. And that they're being effective for improved capital planning, so longer term plans, for moving towards prescriptive asset management, real-time asset management, and what we've mainly covered today for more effective real-time operational management.
David, thank you so much for that. So we've just seen today how a digital twin can transform the day-to-day operation of water and wastewater stormwater networks. Also, it's clear that all what we need to start with a digital twin is a model that we trust and that is kept, maintained, and updated. And all of this aligns well with how Innovyze provides these types of solution. So at Innovyze, we developed our software solution to provide water utilities and municipalities with a very easy and straightforward process to go from simple modeling to advanced digital twin for all the water infrastructure. Engineers can start with our hydraulic modeling software to build their models, run simulations, understand the operation of their networks, evaluate several what-if scenarios, and apply some modifications and enhancement to their system. So all of this is in the planning phase. But once the planning is done, operation team can take over that same model and turn it into an early incident detection and flood warning system and provide their operators with a real-time decision support tool. All required connections and integrations are also available within our live systems to allow automatic update of the model through live data, GIS, work management systems, and from different types of external database. All of this guarantee that your model is a digital twin by continuously representing the latest edition of your infrastructure with real-time information about asset conditions and availabilities, pump status, valves positions, initial and boundary conditions, as well as demand and weather forecasts. Thank you again, David, for highlighting to us the advantage of the digital twin and how it can be beneficial to water utilities in the Middle East and around the world. Thank you, really.
Yeah.
For
you
everybody
are
on
welcome,
yeah,
Eve. I've
thank you.
absolutely enjoyed it.
Thank you.
Yes.
We'll have you in several meetings, I believe, with customers directly to discuss their own projects. For now, I know we're at the end of the session, so for everybody on the call, please feel free to reach out to us at Innovyze for knowing more about the digital twin concept and how it can be built and what are the benefits of having such technology, and especially to link them directly to your own projects. We have a team at Innovyze happy and ready to assist our customers in answering all your questions and share the knowledge we gathered from different projects we have followed around the world. We hope you've enjoyed listening and thank you for your time.